In this question, we're told that a particle is projected from a point A on level horizontal ground and is projected with a speed of 39.2 meters per second. It's projected at an angle theta to the horizontal. The particle is traveling freely under gravity, and after 3 seconds, it reaches the point C, where C is at the greatest height of the particle above the ground. We're first asked to show that sine theta equals 3/4. So we'll start this with a diagram. Let's see everything that's happening: the flight path, the angle of projection, and the particular points we're interested in. So this is the angle of projection, or this is the initial direction of projection. We want to label this, and we want to pick out the vertical and horizontal components. So this is 39.2 cosine theta and 39.2 sine theta. For us to find when this particle is at its greatest height, we're going to be working vertically. We're just considering that vertical motion. We're going to collect Suvat variables for that vertical motion. We don't know the displacement. We know the initial vertical velocity is 39.2 sine theta. The final velocity, since we're looking for the greatest height, is going to be 0. Acceleration is going to be negative 9.8 because we've chosen up as our positive direction. And we know we're waiting for 3 seconds after the point of projection. We're going to use V equals U plus AT. So 0 equals 39.2 sine theta minus 9.8 times 3. And it just takes some rearranging from here to get an expression for sine theta. Sine theta is going to be 9.8 times the 3 divided by 39.2. That gets us 0.75, and because we've been asked for it in fraction form, we'll just write that as a fraction, 3/4. If you notice, I didn't try to do any calculations on my calculator until I had this final rearranged expression for sine theta. So save yourself a headache of doing multiple calculations unnecessarily. We didn't need to type anything until this point. Now that I know sine theta, I'm once again going to rely on a right-angled triangle to get an expression for cosine theta. Sine is the opposite over the hypotenuse, so that gives us 3 and 4, and this adjacent side is root 7. Cosine theta is root 7 over 4. That will be useful later. In part B, we're asked to find the height of C above the ground. Well, we're using exactly the same Suvat variables. We're still talking about the same portion of the journey. Substituting in, S equals 39.2 times sine theta times a time of 3, subtract 4.9 times 9. That gets us 44.1 meters. Point C is 44.1 meters above the ground. In part C of the question, we're asked to calculate the distance AB. Well, B is the point where it hits the ground again, so we're looking for the range of this flight path, the range of this projectile. A was the point where it was launched from, where it was projected from, and B was the point where it hits the ground. So we're going to be working horizontally. Let's collect some horizontal Suvat variables. So the displacement here is what we're looking for. The initial horizontal velocity is 39.2 cosine theta. The final horizontal velocity is exactly the same because we know that the acceleration when we're moving horizontally is 0. The time that it's going to take, well, we know because of the symmetry of the quadratic flight path that the time it takes to go from the point of projection to its greatest height is going to be the same as the time it takes to go from its greatest height to the point of impact with the ground. Or to say we're going to have double the time. If that's half the journey, the whole journey is going to be double the time. So we know it's 6 seconds that we're working with. If you were still unconvinced, you could have done the extra work. You could have worked vertically, setting displacement equal to 0, and finding the time that it takes for the displacement to equal 0, and you still would have got the same answer of 6. So this little bit of intuition and this fact that we know about the symmetry will save you time in an exam. And that's what the top students do. They use efficient techniques, they use their knowledge, they use their intuition and their sense to save themselves, to build themselves a huge amount of extra time in the exam, which is why they get to answer more questions, they get to check through their work, and they just get more marks in general. Efficient techniques make a huge difference in the exam hall. Okay, so working horizontally, if we're looking for the displacement, S equals UT. S is going to equal 39.2 multiplied by cosine theta, multiplied by 6. Luckily earlier, we found cosine theta, root 7 over 4. Multiplying all three of these together, we get a displacement of 155.57 meters. To three significant figures, 156. Part D wants us to state the least speed of the particle. Now the command word here is useful and it's indicative that we shouldn't really be doing any more working out. Our answer is already in front of us. State means just say, just write it down. No more work. It's not calculate, it's not find, it's state. The speed of the particle is always a combination of its vertical velocity and its horizontal velocity. The horizontal velocity never changes. So to get the least speed, we're looking for where its vertical velocity is the minimum. And we know that the minimum vertical velocity is v equals 0. If the vertical velocity is 0, that means that the least speed is when we have a combination of 39.2 cosine theta and 0. If we were to do Pythagoras of those two values, we would simply get 39.2 cosine theta. The calculation there, 39.2 times root 7 over 4. And we get 25.93 meters. If you want the three significant figures, 25.9.